In this video I'm going to do some Surds questions. They'll start off quite simple and then they will become slightly more difficult. So the first ones I'm going to do are a couple of simplification ones. So pen is upside down. So this one here is just square root of 98. Simplify. So when we have something like this and we need to simplify it, what we need to do is work out which square numbers can be divided equally into this. So first I'll just write down the squared numbers. So it's 4, 9, 16, 25, 36, 49, something fucking something, oh yeah, 64, 81. There are more, but we'll just look at these ones for now. Often with something like this it can be a little bit trial and error. However, I can look at this number and go 98, 49, 49 is 1 shy of 50, 98 is 2 shy of 100, so I actually know that 98 is 2 times 49. Now the reason I want to find my squared number, it means when I expand this out like this, as you'll remember, when you have two numbers under the square root, we can separate them out like so, and we can go back the other way. Because this one here is a squared number, it means when I take the square root of it, I get a whole number. So I get the square root of 2 times by 7, which is square root of 49. So the answer to this is 7 multiplied by the square root of 2. And that has been simplified. If I take another question and I do something like the square root of, this is a nice easy one, 250. 250 is 10 times 25, which means I can write this, do a little arrow, as 10 times 25, which I can then write as the square root of 10 times the square root of 25. Because I know that the square root of 25 equals 5 equals a whole number, I then get 5 square root of 10. So that's one of the main things you need to do when you get simple questions like this, that they're just asking you to simplify. The first thing that you need to do is to determine which squared numbers will fit evenly into these numbers, and sometimes it can be a little bit awkward, and you'll need to give it some thought. And you may think, oh, this one I'll try divided by 4, does that go evenly? No. I'll try 16, I'll try 36, I'll try a few different ones until I figure out which one it is, so it can take some time. So next question, I'm going to leave those dotty bits there, I don't actually care that much. This is a quite easy one. So this is the square root of 15 divided by the square root of 3. I'll make that a little clearer. I think I made it less clear, if anything. That's the 15. So we can write this as square root 15 over square root 3. Now if you go back to the rules video, you will see that this can also be written as the square root of 15 divided by 3. So now we need to work out 15 divided by 3, which is 5. So the answer is the square root of 5. And that's how we have simplified that question. Yes, that's correct. So I'm going to do a slightly harder question now, and I'm going to be honest, I completely lifted this question from the revision guide, but I think my revision guide is slightly different to yours, so that shouldn't be a problem. Now this is a grade 8 question, but actually it's not that difficult, and I will try and go slowly. So this one again is a simplification, but we've got a number of things going on. First is square root of 180 plus the square root of 20 plus the square root of 5 all cubed. Now the problem with surds, and what inherently makes them quite difficult, is you don't just follow effectively a simple pattern to come to the solution. You need to look at it and you need to give it a little bit of thought. So I need to think back to my squared numbers. I'll write them down here again. So 4, which is obviously square root of 2, 9, 16, 25, 36, 49, 64, 81, obviously 100 I'll chuck in there as well, and obviously they go 121, 144, 190, 69 I think. It keeps on going. I don't expect you to know all of them, I certainly don't. Now what I can see straight away in this one here, 18 is 9 times 20, because I know that 18 is 2 times 20, 18 is 2 times 9, so 180 must be 20 times 9, so I'm going to write this as 20 times 9. Obviously 9 is a squared number, so that makes my life a little bit easier. And I've got my root 20 here. Now this one's interesting. If this was a squared, then all of this would equal 5, because I'd have the square root of 5 times the square root of 5, which is 5. But what I've actually got is the square root of 5 times the square root of 5 times the square root of 5. And I'm going to write it out like that. Square root of 5 times the square root of 5 times, times in there, the square root of 5. Now I know the square root of 5 times the square root of 5 equals 5. So I can turn that into a 5. And I have my square root of 5 on the end. So square root of 5 to the power of 3 is 5 times the square root of 5. And I'll rewrite this one over here. The square root of 9, actually I'll write it out a little bit more like this. That of course is the square root of 20 times by the square root of 9. I know the square root of 9 is 3, so what I've got at the moment is 3 square root of 20 plus the square root of 20 plus 5 to the square root of 5. Now I've done something to this sum, but I don't think I've exactly simplified it. And the simple reason is I look at these 20s and there is a squared number there as well. It's 4 because 20 equals 4 times 5, which means I can simplify these further. So what I then have is 3. 20 is 4 times 5 plus, again, the square root of 20, which we know is 4 times 5 plus 5 square root 5. Now I'm going to expand these out again, so I get 3 times the square root of 4 times the square root of 5 plus this bit now, the square root of 4 times the square root of 5 plus 5 square root 5. Now I can tell I'm coming to a solution here because I've got lots of square roots of 5s, and my square roots of 4s, of course, because that's a squared number, become 2. So I get 3 times the square root of 4 is 2 times the square root of 5 plus the square root of 4, which again is 2 times the square root of 5 plus 5 square root 5. So let's write that all out. Let's multiply these bits together. So 3 times 2 is of course 6 square root 5 plus 2, oops, you can't see that, plus 2 square root 5 plus 5 square root 5. So now I've got lots of things and they're all in the square root of 5, and I just need to add up all these numbers that come before my square roots to work out how many square root of 5s I have altogether. So I have 6 plus 2, which is 8, plus 5, which is 13. So my answer is 13 square root 5. Now I haven't checked that, so it could be wrong, but you know what, it looks simple, it looks about right. So that was the grade 8 question. I'm going to do the grade 9 question now. So this is as hard, really this is as hard as it's ever going to get with Surds. And again, it's not that difficult, not really. So I have a fraction which is 2 over 2 plus the square root of 3. And what I need to do is I need to write that in the form of a plus b square root 3. Now the first thing I have to do when I'm presented with a question like this is to make the denominator of my fraction rational. Now because I've got this square root of 3 in here, square root of 3 is an irrational number, which means 2 plus the square root of 3 is going to be an irrational number. So what I need to do is to make it rational. Now that means I need to multiply my square root of 3 by itself. But I can't just multiply both top and bottom by the square root of 3, because if I did that, I'd have 3 multiplied by the square root of 3, brilliant. Sorry, square root of 3 multiplied by the square root of 3, brilliant. You know, let's just do it. Let's just show you why it's a load of nonsense. So if I go like that, times square root of 3 times the square root of 3, on the top I get 2 square root 3, on the bottom I get the square root of 3 times 2, 2 square root 3, plus the square root of 3 times the square root of 3, which is 3. Well, that's not helped me at all because I've still got a square root of 3 on the bottom, and what I need to do is completely get rid of it. So to do that, what I need to do is multiply the top and the bottom by the bottom, but I inverse the sign, and I'll show you why that is the case. So I have 2 over 2 plus the square root of 3. I then multiply the top and the bottom both by 2 minus the square root of 3. And remember, because I'm multiplying both the top and the bottom by the same number, this fraction effectively equals 1, which means I'm not changing the value of this fraction. The reason I'm doing this is to make my algebra easier. Okay, so what I get here is 2, and then times 2 minus the square root of 3, and that equals 2 times 2, which is 4, then 2 multiplied by minus the square root of 3, which is minus 2 root of 3. On the bottom of my fraction, what I have is 2 plus the square root of 3 multiplied by 2 minus the square root of 3. Here I get 2 multiplied by 2, which is, do that line there, 4. I get 2 multiplied by minus the square root of 3, so I get minus 2 root 3. Then I get root 3 times positive 2, so I get plus 2 times root 3, and then I have the square root of 3 multiplied by minus the square root of 3, which gives me minus 3. Now here's the reason why we have a different sign to what we have here, because it means that we're cancelling out this 2 to the 2 square root 3 function. Now if this was a positive and I multiply both sides by 2 plus the root of 3, what I'd have here is 4 plus 2 root 3 plus 2 root 3. And then I'd end up with more root 3's than I need. What I want is to cancel them out, so because I've got minus 2 root 3 and plus 2 root 3, they cancel each other out, everyone's happy. So then I'm just left with my fraction that then, so this cancels out, apart from the 3, so I have 4 over 2 root 3 over 4 minus 3. 4 minus 3 is of course 1, so I get 4 minus 2 root 3 divided by 1. Anything divided by 1 is itself, so that all goes, and my answer is 4 minus 2 root 3, which is the same as what I've got here. Ignore the fact that that's a plus and a minus. It doesn't mean that that has to be a plus, but obviously it would be weird if you wrote plus and minus. So that's the answer. That's grade 9. It's not really that difficult.